I'm totally cool with having lightsabers and all kinds of stuff because it makes a super exciting movie. And besides, it's my favorite movie, so it definitely gets a pass. I'm Andy Howell. I'm a staff scientist at Las Cumbres Observatory and a professor of physics at the University of California, Santa Barbara. I'm also the host of Science vs. Cinema. Today, we're going to be reviewing some space and science scenes in film. This is Ad Astra, directed by James Gray. In this scene, Roy is forced to jump from an antenna at a really high altitude. Okay, so this scene starts off Ad Astra, and it's a pretty cool idea of, you think Brad Pitt's an astronaut, but then he goes outside and he's actually on a tower, and then he falls off this tower, and the shot is really cool, and it's an amazing way to start a movie. The problem is it's just not justified at all. What I like about it though is it's based on reality. There was a test that the Air Force did of high altitude parachute jumps back in the 50s, and this guy Joseph Kittinger actually did not a fall off a tower, but a fall off, I think it was a balloon, to see what it would be like to do that exact stunt that was done in the movie. What happened was the air was too thin and he started spinning, and he spun so fast he actually lost consciousness.
Control, McBride. I'm in a spin. Atmosphere's too thin to stabilize.
So I really like basing that kind of thing on reality, sort of subverting our expectations into thinking he's just a regular astronaut, but he's in a tower on Earth. The problem is there's no scientific reason to have a tower like that. What they say in the movie is that it's to communicate with aliens. Well, we can already do that today with radio, dishes on the ground. With radio, you don't have to put it above the atmosphere. They could have made it so that it was a space elevator though. That would have been super cool. That's this idea of you build a tower to space and then you can ride it up, and instead of launching a rocket, you can just get off your space elevator in orbit. But sadly, they just went with this uninformed thing of building a tower for no reason. This is Star Wars: A New Hope, directed by George Lucas, and in this clip, Luke Skywalker admires the twin suns of Tatooine. Man, do I love that scene. Star Wars is my favorite movie, and I would make a case for it being the best movie in history. And that's one of the best scenes from it. I mean, just that John Williams music, the Luke as he's about to leave home and embark on this great adventure. You see these twin suns, so visually you just know we're on another planet. It works so well. And astrophysically, it actually tells you a lot about the world of Star Wars. Actually, most stars in the sky, maybe not quite half, are binary stars. So like we have one star, the sun here, but many stars are two stars orbiting each other. So the question is, how do you get planets around a two-star system? One possibility is that you have planets going around one of the stars, and that's actually the case in Avatar. And then the two stars orbit each other, but the planets are just going around one of the stars. In that case, you would get sometimes the stars both being aligned in the sky, like during the daytime being in the same direction. At other times, you might be in between both of the stars, which if you think about it as your planet rotates, means that there will always be a star up and you'll never have nighttime. So those are quite weird. But the kind that we see in Star Wars is two stars orbiting each other and then the planet orbiting the pair of stars from farther away. How do we know this? Well, in Star Wars Episode 3, they show the same sunset. And so that's like 18 years earlier, and yet the stars are about the same size in the sky, and they're both rising and setting together. And the fact that they're sort of yellow and orange stars tells you that they're very close to the mass of our star, because the color of the star tells you the temperature. At the time Star Wars was made in 1977, we didn't know about planets around other star systems. But today, we have, for example, the Kepler satellite, and it has found thousands of planets around other worlds, including a planet around a binary star, very similar to what we see in Star Wars. And in fact, scientists informally refer to it as Tatooine, even though its real name is Kepler 16b. This is Black Panther, directed by Ryan Coogler, In this clip, Shuri shows her brother T'Challa some of her new inventions.
I have great things to show you, brother. Here are your communication devices for Korea. Unlimited range, also equipped with audio surveillance system. Check these out.
So we've got this laboratory in Wakanda, and it's a great example of Afrofuturism where, in this case, they're imagining a country who had great resources and technological development that was spared the horrors of colonialism. So they weren't set back by, all of these bad things that happen in the real world. So I just love that, and I love seeing all these inventions. And Shuri is just such a great character. Her sort of glee with which she talks about all of her inventions and her relationship with her brother and how she's sort of making fun of him and everything.
And what are these?
The real question is, what are those? Why do you have your toes out in my lap?
You get the sense of humor that scientists have. You get this joy of discovery and of new inventions. And I just really do love seeing a Black woman in this role that is not typically what you see. You usually see a white man in a lab coat, totally humorless, just crazed about technology or something like that. But that's not what scientists are like. I see more of myself in Shuri than I do in most portrayal of scientists in movies. She captures the essence of science better than, say, in Armageddon or Independence Day, some nerd in a lab coat. One of the things I really like about the narrative of Black Panther is it's based on this asteroid that came to Earth and crashed, and it's made of vibranium. And so part of the thing here is that there's this culture who has resources that help them sort of get ahead, but then it helps them shield themselves from colonialists who aren't able to come and get it. This same kind of thing has happened on Earth in various ways, almost identically. We've had iron nickel meteorites. That's one of two types of meteorites. They're either stony or iron nickel. And before cultures had the ability to mine iron, they were able to mine this meteorite, been able to get the iron from it, and they don't always get a huge technological advantage. They have in a couple of cases, but they usually have used it to make ceremonial things like daggers and pendants. One of King Tut's daggers was made of meteoric iron. We can tell that by analyzing the composition. And the Inuit, even though people around them had Stone Age technology, there's a case where a group of them were able to make like metal fish hooks and spear tips and things like that. It's astounding to me that that kind of thing has happened, but even more surprising is that every time where a culture has had this, colonizers came and took the meteorite away. There's only one case where that didn't happen, and that was because the meteorite was like 80 tons and people couldn't move it. So this thing of getting technology from space and then colonialists stealing it unless you hide it from them, that is real. So I really love the fact that they were able to take this astrophysical story but then weave it into a narrative that is very meaningful for both the characters in the movie and to a lot of people. It's affected all of our lives on Earth. This is E.T., directed by Steven Spielberg. In this clip, Elliot's home gets invaded by astronauts after E.T. falls ill.
Leave him alone.
All right, so what's going on in this scene? We've got Elliot and E.T. who are really vulnerable, and at the same time, these scientists are coming into the house, and their faces are obscured. We really have lost their sense of humanity. They're breathing really weirdly, and they're like these home invaders. So they're the real, clear villains. These are scientists who just want to study E.T. I mean, wouldn't you want to study extraterrestrial life if it came to your planet after thousands of years? Think about it. E.T. has knowledge of physics way beyond whatever we do. He has knowledge of interstellar travel. It answers the question, are we alone in the universe? And he can revive things from the dead. Okay, so this could be the key to all of us having immortality. And yet somehow Spielberg makes us root for a kid to keep all of that away from us by making scientists into the villains. Look, I'm a scientist. All we want to do is study things and make the world a better place. So I think there was room in the movie to make the scientists heroes and also have this kid and alien relationship. This is Avatar, directed by James Cameron. In this clip, we're introduced to Pandora's floating mountains. So I really like a lot of aspects of what we're seeing here and in Avatar in general. We've got these Na'vi, these creatures that are like really long and skinny blue creatures, and they've got these sort of horse-like creatures with them going around on these floating mountains. Okay, so everything about that has some basis in what James Cameron was trying to create here with this movie. We're on a moon around a planet around Alpha Centauri, one of the closest star systems, so it makes sense that that's one of the first ones that we would visit. And they allude to the fact that the gravity might be a little lower on this planet. I think maybe that's one of the reasons they're very tall and long. They're just evolving under a different set of circumstances. In fact, he had biologists create a whole evolutionary ecosystem there. You know, James Cameron is a very smart guy, and he actually did talk to lots and lots of scientists. The floating mountains there are based on a real thing involved in superconductivity. It involves magnetic field lines and the fact that you can actually have some piece of metal under certain conditions float above something else. Now, you can do that with light things. A whole mountain would be a little tricky, okay? I actually talked to James Cameron about this, and he said, well, I actually did the calculation, and the magnetic fields would be so strong it would rip the hemoglobin out of your blood, okay? But he just said, well, it was just too cool of a visual, I couldn't not use it. So I can get behind him on that. He did his homework. He knows that this is a principle that makes a really striking visual. It really says alien landscape, and yet those are based on some mountains in China that are real mountains. They don't float, but they look a lot like that. So he's really making it ring true while being alien at the same time, and that is quite a delicate balancing act. This is Armageddon, directed by Michael Bay.
Your Stouffer's pot pie's been on the table almost 10 hours. I want a divorce.
Daddy, I'm onto something big here. I don't know what this is, but it looks like something's burning up there. Go get my phone book, will you? Get my phone book. Get those names of those guys from NASA.
Excuse me, am I wearing a sign that says Carl Slade?
Go get my goddamn phone book!
There we have some kind of amateur astronomer who's got this massive telescope apparently at his house, but just nothing in that scene is right. He's got a lounge chair somehow, and he's looking through an eyepiece. He's got the lights on. This is just not how you do astronomy, okay? We use telescopes in really dark places. Amateurs don't usually have a big, huge telescope like that, although maybe a few do. But then you don't look through an eyepiece anymore, okay? We take digital images. This is a popular misconception caused by, movies and things like that. We use cameras before there were digital cameras, and now digital cameras to record things. Both professional astronomers and amateur astronomers do not look through an eyepiece except for fun. You might point your telescope at the moon and look just to see something with your eyeball, but if you're really trying to discover something, and especially if you're going to make a discovery that no human has ever seen before, you can't do it with your eye. You have to go deeper like you can with a camera. And a camera you could expose for an hour. Your eyeball only gets photons from the last few seconds, so you can't make a big discovery using your eyeball anymore. There are amateur astronomers out there, and they do make contributions to science. They actually do discover comets and asteroids sometimes, but they don't do it like this. Even if you're an amateur level astronomer, you gotta use professional tools at a professional level if you're gonna make the really huge discoveries. This is The Martian, directed by Ridley Scott.
I can't get to you, Mark. You're too far.
I'm not gonna make it.
I know.
Beck, unhook me. I'm going after him.
Commander, I got this.
So in this scene, Mark has a capsule, but he couldn't quite reach where his crewmates were there to rescue him. They're in a slightly higher orbit. So he decides he's gonna punch a hole in his suit and use a basic principle of physics that for every action, there's an equal and opposite reaction. And the gas shooting out of his suit will propel him to reach his crewmates there. That's an interesting idea. It's based on, some reality. This is how thrusters work but it's not that well executed. For one thing, that kind of thing is super unstable. They try to show it a little bit in that scene where he's sort of moving his hand around, he's sort of flying every which way. If you are not directly in front of your center of mass, you'll just actually rotate around. And this has happened before where, like in one of the Gemini missions, a thruster got stuck and the capsule just started rotating. And in fact, Neil Armstrong almost died before he ever went to the moon. Luckily, he was able to control his thrusters and get it back under control, but it was a really close call. And you can't really get enough thrust with the gas escaping from your suit to really transfer orbits that way, usually. It depends on the exact specifics, and they actually had some decent numbers in there about the relative velocities that you would be going in that particular case and the relative velocities you could achieve. The crew commander there had on a big old backpack, and that's supposed to be like a maneuvering unit, and astronauts really do have things like that they have used in the past, and that actually gives you much better control, thrust, everything else. So she should have been the one going to get him, not the other way around. This is Hidden Figures, directed by Theodore Melfi. Hidden Figures is based on the true story of Katherine Johnson and two other women who really did help the space program achieve its goals through their brilliance and hard work.
Euler's method.
Euler's method?
Yes.
That's ancient.
But it works. It works numerically.
Yeah, the math they're actually trying to solve there is real math, and that Euler's method is a real method to try to solve math problems like this. So I'm really glad that they got that part right. It's a little bit of a tweak because it's a movie. Mathematicians don't really talk like that to each other and really explain the context of every method they're using. We all know it. So you say, Euler's method, they're like, oh yeah, okay, yeah, I'll just try it. You know, you don't really set the stage, but that's okay, it's a movie. You have to explain to the audience what's going on. So what's going on is she has had this insight that allows them to solve this equation that was giving them a really hard time, and that's really this stroke of genius that then helps the space program achieve its goals. But you know, of course, she's also a black woman, and so as other scenes in the movie showed, she had been kind of marginalized, maybe not believed so much, and yet she's the one that can come through and triumph in the end. So it's a really powerful scene, and the whole movie's full of great moments like that. It's a really, really great movie. I did not really know that story, and why didn't I? I don't know. But that's the power of Hollywood. Now everybody knows these stories, and people are starting to have just a greater recognition of these women's contributions to the space program, but that's going to inspire a whole new generation. And that's so important. If we're only using a tiny fraction of our Earth's population of people's brain power, then we're just seeing a teeny piece of the picture. If we can actually expand that to use the whole Earth's brain power, we will all be better off as humans. This is Guardians of the Galaxy Volume 2, directed by James Gunn. So this is a space fantasy. It's not really trying to be rooted in real science. It's a very comic book kind of narrative. But what's amazing to me is that you can still show that on screen and not have you disengaged. That's the power of really good storytelling. I mean, you can see some of the tricks James Gunn uses to achieve it. He makes this sort of like almost comically beautiful land of candy and wonder or something at the beginning with these fish jumping through fountains and cool, amazing vistas. And then you reveal a little bit about the characters through comedy and things like that, and then you get the sense that maybe things aren't all quite what they seem. So it's okay to have a little fun. Not everything has to be perfectly scientifically accurate. It has to fit the tone of the movie. My policy is do whatever you need to do to have some really good storytelling, but just don't get stuff wrong because you don't know any better. And this isn't dealing with anything we know about. This isn't talking about Mars or the Andromeda Galaxy or something. It's just a made-up comic book fun story. This is Interstellar, directed by Christopher Nolan. In this clip, Cooper is entering a black hole.
Approaching the event horizon. Port side, dipping down beneath it. To go through it.
First of all, I love the rendering of that black hole there. They actually had a team of scientists and movie people, I think it was something like 20 people, make an accurate black hole using general relativity and like a simulation. They actually published a couple of scientific papers on that, so we learned something. Almost no scientist realized that you would actually see that arc over the top of the black hole. When we saw it on screen, we're like, of course! But until they actually did the simulation, most people didn't realize that.
Screens. Any interference. Losing control of the stick.
So they had some sort of spray of, I don't know exactly what it is, if that was exhaust from the spaceship or something. It looked kind of weird and trippy. Then he just sees sort of normal stuff. In actuality, at that point, you're probably moving at something like 97% of the speed of light. It's all these relativistic effects take over. It really then depends on the angle that the light rays are coming at you and all kinds of other super weird stuff that we're just not used to. So stuff would get distorted. Everything would be constrained into some narrow band and you would see blackness around, but you'd see stars in some narrow region. You'd have magnification. The black hole itself would magnify the light so that you'd get double images of stars. Stuff would get really bright. All this would change, and it was a real lost opportunity they just didn't go for. So that's a bit of a disappointment. This is RogueOne, a Star Wars story, directed by Gareth Edwards. In it, we're introduced to the planet Wobani, one that's enshrouded by clouds. Okay, so the history of this goes back to one of the writers of the movie wanted to ask me some questions about astrophysics for writing one of the scenes. Now, that scene actually didn't end up showing up in the movie, but I said, while I've got your attention, there's a whole bunch of cool stuff I'd like to see in science fiction movies that I've never seen before. Like, what if you're on a planet and you're in a galaxy you're on the edge of the galaxy, and so like in the night sky, you wouldn't see stars. You would just see a giant galaxy on one side. Or what if you're on a planet that is like melting away because it's so close to the sun? Or what if, we see like super planets that are like many times the mass of the Earth and gravity is really heavy and there's carbon that are like made of almost like diamond. Astrophysically speaking, the world is incredible and we've never seen most of that on screen. So one of the things I said was, how about a planet in a molecular cloud? That's a big, dense field of gas. It could be so dense that it looks black. So if you were on that kind of planet, you might not even develop astronomy because you wouldn't see stars in the sky. You might not even know that there were other things out there. And so I don't know if it was based on that comment, but I was really excited to see when I saw RogueOne that there's this planet Wobani and the establishing shot has all this gas around it. And then when you go on to the actual planet, there's also clouds on the planet. So it at least gets this spirit of sort of foreboding and obfuscation, obstruction, and maybe that, thematically ties in a little bit with our hero, Jyn Erso, being in prison there. So we've seen quite a range of movies, some that get the science exactly right, and some that don't do such a good job. To me, the best cases are ones where the movies are inspiring. They portray scientists well, they make epic adventure of awe and wonder that makes you want to know more and makes you curious. And those are just great things to inspire the next generation of scientists, but also to make the average person who sees the movie more curious and a better citizen. Whether it comes to disease or global warming, there's all kinds of things where science really impacts our society. So if we can make more scientifically literate people, all of our lives improve.